All right, so welcome guys. This is the ultrasonic method of liquid level measurements. In this method, we see that an ultrasonic transmitter is mounted on top of the tank for measurements of either solids or liquids. You can see the sketch here. You can see the tank. The ultrasonic transmitter is up here. The ultrasonic transmitter also has embedded in it a receiver, ultrasonic receiver. And so the transmitter sends out a signal, high frequency signal that goes to the surface of the content, whether solid or liquid. And that surface, immediately the signal reaches the surface, is reflected back and is picked up by the receiver. Once it's picked up by the receiver, the time taken between the sending and receiving it is noted. And that time taken is proportional to the height of the empty space in the tank. That is H prime, as you can see here, H prime. That time is not proportional to the height of liquid in the tank, but proportional to the empty space that doesn't have any contents from top to the surface of the liquid. Thereby, if that height of the empty space is determined, then the height of the liquid can be determined by subtracting the height of the empty space from the total height of the tank. So the total height of the tank is capital H, the empty space is H prime, and the height of the liquid is H. So H can be calculated by subtracting the empty space, the H prime, from capital H. That is how the height of the liquid can be determined. Now, the time taken by the beam is a measure of the distance traveled by the beam. The height of the liquid is a measure of the distance traveled. It's proportional to that. So as you can see the tank here, we have the ultrasonic signal here. We have the tank, the ultrasonic transmitter and receiver here, and the liquid or solid that is the content of the tank is air. So that is a simple mechanism by which ultrasonic method is being used to determine the height of liquid in a tank. All right. Now, the time taken T is proportional to the H prime, which is actually proportional to H minus capital H minus small h, and that is H prime. So after determining the H prime, then we can use it, simple equation like this. H can be determined as H minus H prime, minus H prime, and that is it. H minus H prime. H minus H prime. That is the height of the liquid in the tank. Now, we want to quickly talk about the measurement of a liquid level using gamma rays. The similarity between the two of them is that both of them are using rays to take the measurement, but there's a difference in the way they are set up. For gamma ray liquid level measurements, a source of gamma ray is placed at the bottom of the tank, and there's a gamma ray sensor that is placed outside the tank, near the top of the tank, outside but near the top, such that the gamma rays that are being radiated out from the bottom of the tank will be picked by the sensor at the top. Now, when there is a liquid in the tank and then it's full, there will be little rays received at the sensor, and that means there is the rays, the intensity of the rays received is inversely proportional to the height of the liquid in the tank. When there is much rays received, it means there is lower content in the tank, lower level of liquid in the tank. So we can see that it is inversely proportional. But if maximum radiation is received, it means the tank is empty. So the complete radiation will be picked by the sensor at the top of the tank. This happens because as gamma ray is being sent out from the bottom, the liquid in the tank will actually absorb a part of the rays. So when there is much liquid, much of the rays will be absorbed and little will be received by the sensor, such that little rays received indicates full tank or very high level of liquid in the tank. So the output received is inversely proportional to the liquid level. And then the output of this sensor, the sensor at the top of the tank, is designed to go out in form of pulses, and the pulses can be counted using a counter. And so the output of the counter is directly proportional or inversely proportional to the height of the liquid. But the counter may be directly calibrated in terms of the liquid level. So that is how the gamma rays method works. This is the sketch. We have the tank. Liquid is inside the tank, you can see. We have the source of gamma ray placed at the bottom of the tank. We have the liquid there that absorbs these rays as they are going to the sensor at the top, outside the tank at the top. So, and then from the counter, from the sensor, a signal goes to the counter that counts the rays received to determine the level of liquid in the tank. And that is how it is. So you have a quiz in this small lecture, and the quiz is that each and every one of you should sketch the gamma rays method of liquid measurement and sketch the ultrasonic method of liquid measurement, and then sketch it into a paper and then scan it to me. So I want to receive this in not more than 30 minutes after this video is uploaded. So the quiz is that you should sketch the ultrasonic method of liquid measurements. Only a sketch, and then the gamma rays method too. The second one is a gamma rays method. Sketch the gamma rays method too. That's just it. So I want it to be scanned. Just sketch it on the paper, use your phone to scan it, and then forward it to me. So that is the quiz. So that is 5 marks of the course. So don't forget to give a like to the video and subscribe to the channel. Subscribe to the channel if you have not done so. Do so, because it will earn you something also. Don't forget, it will earn you something. All right. So that is how we are going to end this. So I'm expecting your quiz to be submitted in a very short time to this time. The video is going to be uploaded right now. So until another time, I'm saying bye-bye.